Cool. So observability, is it just another buzzword? You know, how much we love buzzword. We have been talking all about building something today. Let's have a look at how to actually looking after something. But then isn't observability, we always have it anyway. Is it even a problem at all? So I'm Inny.
I'm Andrew.
So today we want to look at observability for everyone. So first of all, is it just another buzzword? We love buzzword. We think of another buzzword every 2 seconds. Well, the truth is, observability or an observable system is nothing new. It was first mentioned by Dr. Coleman in 1961 in one of his papers about general theory of control system. It said, a system is observable if the behavior of the entire system can be determined by only looking at its inputs and outputs. Pretty clear, pretty easy to understand. I think if we put it in our context, it means that we should be able to understand the states of our system at a particular point of time without really knowing the nitty-gritty of how the services interact with each other. We should be able to just look at it by looking at the input and output of the system. Now you'll be sitting there thinking, oh, did I just walk in another talk about logs and metrics? How boring. Well, maybe actually, I don't know. But before we determine that, I think Andrew has a story to tell.
So in order to figure out how we got to where we are, I'm going to tell a story that will hopefully have some familiar elements to you. This is fairly indicative of the organizations I've worked with through my career, and will hopefully be familiar whether you've worked in startups or whether in big enterprise environments. Typically, we'll start off like this. We've got an app running on a host and a database on another host. This is a really simple system. All we're doing is testing an idea. We don't have any customers, we don't have any users right now, so there's nothing really to look at. All we're doing is seeing if people will use it, and if it falls down, it doesn't really matter. But if we fast forward a little while, we start getting some customers, whether they're internal customers or external customers, and suddenly we've got folks who care about whether this thing is up or down. We start to care about stability. So this organization or part of an organization has found some infrastructure folks, and our infrastructure folks love Nagios. So we're going to start shipping some host level metrics. These are really geared towards the operating environment rather than the application environment. And we're starting to see the traditional DevOps responsibility split. What we've got here is ops teams responsible for infrastructure. So their metrics reflect this. They're responsible for keeping things up, for knowing whether a host is about to fall over. And we've got devs focused on app performance, or hopefully focused on app performance. Right now, there's no one focused on customer happiness. There's a great quote from Charity Majors, who's very big in the observability world, who says that it's possible to have 5 nines of availability, but you can still have really pissed off customers. And it's partly because of this traditional DevOps responsibility split, because your delivery teams, your application teams, and your infrastructure teams aren't aligned to a single vision. They're pulling against each other because they've got different responsibilities. So if we keep going, we've suddenly got more customers. Our business is growing, and we need to scale. We've run out of room to vertically scale. We can't keep putting this thing on bigger and bigger boxes. We've run out of space in our VMware cluster. We can't provision a big enough host anymore. So we've had to get our devs to remove all the things that stop us from scaling this thing horizontally, from putting more of them out there behind a load balancer or something. And we've had to cluster our database just to cope with the scale. What we've got now is that we've got so many machines that it's too hard to log on to an instance and just sort of tail the logs to see what's going on. So our devs have found out about this great new thing called Elasticsearch. It's got Elasticsearch on Logstash and Kibana. And we're starting to ship all logs to this central location. One of the challenges we start to see here is it's a text-based format. We've had to learn this sort of clunky Lucene syntax to figure out how to parse that and query it. And we've got predefined indexes. If we want to change that index to try and dig into the data in a slightly different way, we've got to go and talk to the team that runs that logging stack. And that if we're in the middle of fighting an operational incident, we've already lost the chance to learn something about our system at that point. So we're already starting to lose data essentially. So our devs sort of jump on the bandwagon and they start to want some of these metrics so they can start to find out how the system, how the application itself is performing. Because the infrastructure folks are not going to give them access to Nagios, like no way in hell. So the infra folks found out about this great thing called statsd. It's just a server that runs up and they can throw metrics at it from all over the app. So they start to dot little metrics harvesters like throughout the app, and things are going really well for a while. But then the devs, they get really sick of having to ship all these metrics. Like every bit of new code they write, they're having to instrument more stuff. So about this era, in the industry, we got things like application performance monitoring. So things like New Relic started to appear. And these are great because as a dev, I can just drop a new package in my application environment and suddenly we start to ship all the metrics. We're getting really great insight from across the application. But now we've also got 4 different interfaces that we're having to try and triage incidents across. And that's starting to get really painful because trying to correlate an outage between statsd, New Relic, Elasticsearch, and the infra team, whatever they're doing, that's starting to get really, really clunky. But at this point, we've got just enough that it's like we're starting to move to the cloud and we're throwing like more and more instances of this thing. We're really getting into the tens and hundreds of instances of stuff. But what we're getting now is that the overhead of managing some of these things is just too big. So we've got the devs and the infra folks decided together that we're going to get Splunk, because Splunk is this amazing thing. It can do everything. We can get rid of our statsd. We can ship all our metrics and all our logs into something like Splunk, and we're great. The challenge here is that Splunk gets more expensive. So we start by shipping everything to Splunk, but then we have to start turning logs off in different environments because it costs a lot. And we've had to go through this huge engineering effort to move everything over to point to Splunk, because it's not just a simple configuration change. It's a fundamental shift of the way of where and the method that we're sending everything. So all of the apps need to change. All the places we've instrumented the host, they're all changing. And this is a symptom of this sort of mentality that particularly in the operations space, that we need one tool to rule them all. We've had this culture of monoliths within the way we build apps for a long time, but we've also behind the scenes had a culture of monoliths in our operations world as well. And monoliths aren't necessarily a bad thing, but the thing that they hold us back from is the ability to respond when a system needs to evolve, and to be able to evolve the capabilities that these monoliths are made up of independently. So every time we want to change one thing, we have to change everything. We've also, the other thing that's tied to this is a lack of investment in operational problem solving. We're not trying to change the way we do things. All we're doing is throwing a new tool at it and hoping that that'll fix the organization. And I've definitely seen this, exactly like that. We throw Splunk in because our logging is not working for us, so we just throw a tool at it. We've seen sort of an unwillingness to put the thinking and time into investigating these new patterns. So as our systems grow, where our teams are, the organization has grown now to the point where we've got so many people working on this app that they're not able to coordinate with each other anymore. And in order to sort of keep growing the organization and to grow more teams, we've had to split out some microservices so teams can work on things independently. And that's going really well. We're already in a cloud environment. We've only got a few things, so we can sort of drop New Relic into those new microservices that are coming out. And sort of everything just keeps working, as normal for now. But as we grow and we get more and more microservices, deployments start getting harder because we've had to orchestrate a whole lot more things. So now we're in the cloud, and we now can have some Kubernetes. So we throw Kubernetes at it. We can shove our app into that, and all of a sudden we've got this explosion of microservices coming out. But at this point, because the particular licensing model of Splunk, it became way too expensive. So we had to basically port everything, that used to send data to Splunk is now sending data to CloudWatch. And we're still sending stuff to New Relic, and that's kind of expensive too. But at least CloudWatch can get all the data and some extra stuff now. But it is a huge pain to query anything through CloudWatch because it's not really a query interface. CloudWatch logs, CloudWatch metrics, they're all a bit of a pain. And now we realize we're not, as we start to move into this new environment, devs are having to take more responsibility for what they're running. Part of the move to microservice is the shift in the operating model of our organizations, and delivery teams have to start taking more responsibility for operating the system. And the infrastructure folks don't really like them touching their tools, so they need something new like PagerDuty. So they've gone through to hook up, work out how to wire up these CloudWatch alerts to something like PagerDuty. And this is where we fall into the trap of developer experience. If you've ever tried to hook up CloudWatch metrics, CloudWatch alerts, and PagerDuty, it is one of the most verbose things in the world. It shouldn't be this difficult. I should just be able to say, I'm on an alert on these conditions, done. But what we actually have is a how-to that takes about this long, and this is the clicky way of doing it. It's surprisingly there is a lot that you have to do, and that's not real fun. When you want to focus on operating one of these things. So we continue. CloudWatch is crap for looking at alerts, so we've had to wire up something like Sumo Logic to hook into that. We don't have enough sort of natural insight into what's happening, so we've jumped on the bandwagon with time series databases, and now we've got Prometheus too. And Prometheus, it just works. It sort of magically, reads everything out of Kubernetes, and it's great. But the thing that Prometheus and a lot of other things have promoted before it is dashboard culture. Dashboards are great for telling us about stuff we already know about, but they're really bad at telling us about things that the unknown unknowns. And what we really wanted was just a query interface. We've just got these sort of static dashboards. So this is about where we are with a lot of organizations. We've got a lot of different tools, and sort of it's really hard to start correlating between them.
Doesn't that kind of sounds familiar? Hoping I'm getting a bit of some nods somewhere saying that, yeah, I've seen something similar before. Well, because I have. Well, I mean, as what Andrew mentioned, our industry had evolved quite a fair bit in terms of how we design our architecture or how we actually provision or create our infrastructure. So instead of monoliths, most of the time we're trying to build more microservices now. And instead of static infrastructure, we are looking more into dynamic infrastructure now, which usually in the form of cloud. Interesting enough, the move to dynamic infrastructure actually accelerates the adoption of microservices. So now when we look at observability, we used to have logging and metrics, and does that still work? I think with that story, we can tell that, well, I don't think it still really works. I just can't imagine myself being wake up at 2 a.m. in the cold Sydney or Melbourne morning, using that tool set, 5 different tools, information everywhere. That doesn't set me up for success at all. It's not actually helping me to reduce the mean time to recovery, but it's an important indicator for happiness for our customer. So how can we get to this stage? Why are we doing this to ourselves? We have suffered enough as an industry. We can do much better than this. And look, metrics and logging, it might work in a monolithic world, but it doesn't work now. It needs to be a lot more humane than this. We need to make on-call actually fun again. Interesting enough, me and Andrew actually really enjoy fixing production issue. For me, it's actually quite challenging. I feel like I'm a detective, that I'm looking through stuff and trying to figure out what goes wrong. But with the tool set that we have today, this is like walking into a modern crime scene and all I'm given is a magnifying glass. Well, good luck to me to be able to find a criminal, really. So we need to do something about this. So how do we fix it? Now, I think we recognize two major issues that we're looking at. So the first one is about the use of logs and metrics. They are both really important information that we actually need, but they are separate. We need to like correlate it ourselves manually, very clunky and can be error prone. The second thing is what Andrew showed us, there is system everywhere, data everywhere, and there's different interfaces to query all this. So I would like to actually look at the first problem, which is metrics and loggings. We are lucky enough to be able to work in different domains and learn different good things from the different domains and incorporate that into our infrastructure world. So one thing that we actually talked about a lot today is event-driven architecture. So let's just a quick recap. We have an event stream. We have a producer producing an event, usually a business event like a purchase. We have consumer that consume these particular events because they're interested about it. So number one is this is actually a quite nice and unified way to collect stuff. But then the second thing that like interests us is logging and metrics. You know what? Maybe we can replace it with something called events. Or can we? So let's have a look at an example here. We have a customer with this particular customer ID trying to log into a system at this time on this date. It took that many milliseconds and we're getting a 401 response. So let's do a comparison of how it is represented in metrics and logs and also how we represent it in events. So in terms of metrics, I mean, metrics is good at remembering numbers. So in our case, it's obvious that the request time will be recorded inside metrics. So we can get mean and median, whatnot. And we can also like give it more richer context by giving it tags. But just imagine like you're getting one tag for every single customer for a different combination of status code. It can go really messy very quickly. So in comparison, if we represent this as an event, not only are we getting the request timing, we're also getting a lot of richer information, or the one that we are actually expecting, and also something like an API version that we are running, the build number, which environment, and many more that you want. The one that your future self, when you're doing debugging, you will thank yourself for adding that in. So in this case, metrics doesn't have enough information. They're important, but I can't just use metrics to help me debug stuff. How about logs in this case? Well, logs is a little bit closer to events. We can actually record everything in logs. But I don't know about you. I'm not a big fan of looking through this big, giant thing with exception trays everywhere. Yeah, we can do a search on it, but then the thing is, logs are in a particular format usually. So if someone decided to change the format of logs, then your search query will stop working. Your alert will stop working. Whereas as an event, it is very consumable by computer, by other stuff. So we can easily add or remove stuff without affecting the rest of the system. So what we are saying here is we think that we can use events to replace logs and metrics. And not only it can replace it, it actually allowed it to have more context and it adds more rich information to it too. So in this case, we're saying that, well, look, let's replace logs and metrics with events, but then it still doesn't solve the problems of having data everywhere.
So we've now got all these events, and if you accept the premise that events can carry far richer context than metrics or logging just by the nature of the format, then we've got to shove them somewhere. And like what sort of stuff, what infrastructure, what tooling around this do we need to support our event-driven needs? Well, one of the things we want is a single place to access all that data from this huge variety of sources coming in. If we've got a microservices environment, we want data from all of those. We want all the operational events. We want simpler ways to get that data into central places. It should be easy to ship that. And if we ever need to replace the way we ship it, that should be easy to change. We don't want to pre-aggregate any of this data. We want to store the raw data. And this is in the customer world. If we're working with big data, there's no way we would want to store aggregated data. There's rich data. There's rich insights we can draw from sort of novel analysis of this data. We want, despite storing the raw data, we want fast querying. We want some way to carve through this data, to slice it up, to figure out what is actually going on in the heat of an incident. We want to make it easy to evolve alerts. We want some way, like one of the sort of key operational tenets these days is to evolve your alert systems and to figure out and really refine those alerts so they are useful for you rather than being just noise, because there's no way to destroy the morale of a team quicker than over vocal alert systems. We want to think in standard formats rather than standard information. We want different applications to ship the data that matters to the operation of that service. We want to think about pipelines. We want ways to build tools on top of these data sources rather than having to duplicate them. And we want to avoid single tools. We want to allow as many secondary indexes which will let us use the best tool for any job. Because we're not saying that all the tools that we've seen, we're not saying they are bad. It's bad when we rely on one at a time. So if we can use them all at the same time without these clunky, convoluted ways of shipping data around, then that's great. So one of the things we've figured out is that this is exactly like a big data platform that we'd see in any large organization. In the data world, we've really moved to unlock data and move it between systems seamlessly. We've removed assumptions about how the data should be used, and we're moving in the direction to upskill more teams to be able to transform the data to their needs, rather than relying on another team to sort of convert the data into a form that is useful. And this should be a no-brainer for our operational needs. If we pair it with things like data catalogs, we can start to query against other teams' data and to know what that means, and and all we need to do is acquire some sort of central metadata repository. And we stop caring about the cost of storing data, in the big data world. We just, that's what object stores are for. They're really, really cheap to store huge amounts of information. But suddenly we get really cheap when we start thinking about storing, a lot of operational data. So if we think about the key things that, a modern data platform gives us, it gives us evolvability. It gives us the ability to change parts of our operational systems without massive engineering effort. We're actually expecting those systems to change and can sort of build and evolve those accordingly. They're scalable because by using tools like Kafka, we can shove a lot of data into these things and grow our organization around them. We start to build in reliability of these tools for all the reasons we've seen earlier today about sort of event-driven applications. We can sort of decouple them in such a way that they can operate independently. And we've got integrity. For our operational needs, we don't care so much about catching every bit of data, but in a lot of cases we can do that without worrying too much without having to do too much extra work, because the data platform will help us with that.
So by now you're like, all right, well, you talk about this approach. How about alerts and dashboard? Are they still relevant in this case? Well, yes, in particular alerts. And remember we talked about event-driven architecture that we can use as an inspiration. Well, how can we represent an alert? Well, it's just simply a consumer. So this particular consumer, we can write it in code. So any language, your favorite language, Java, Golang, Python. So you can codify the rules that would define what a healthy system is. So then it will consume this particular event. Looking at this event, when this happens, is our system still healthy? If it is not, then it just creates an alert, piping it back into our event stream, and then we have another consumer that consumes it, and then you can just do anything to it. At the end of the day, it's just code. So remember the example that Andrew talks about, integrating with PagerDuty, ClickKey. Yes, we can write it in YAML, but I don't know about coding in YAML really. So at the end of the day, if we represent alerts as code, look, it's just code. And we can do all the great practices that we always do and always love. For example, I always get asked, well, we want to create this alert traditionally. How do we do it? Well, we write a particular query. How do I test this query? Well, let's just deploy it, create a fake error, and hope for the best. But look at this. This is just code. We can write unit tests to it. We can validate it before we deploy it into our environment. And what we actually find more often now is the notion of what does it mean when we have an outage. So because of the way that we build microservices, a lot of time it needs to be like a different numbers of microservices that are actually not working, and sometimes in a particular order too. I try to write that into a query, but I can say that it is actually quite impossible. But look at this. This is just code. We can define it easily as code. So second thing is, do we still need a dashboard? I mean, like, this is kind of a complicated topic for me because I used to be a very dashboard-driven person. I love my dashboard. But then there was once someone asked me this question. It was like, well, yeah, if your dashboard is green, why do you bother? Like, it's working. Why do you want to know about it? The only time you want to know about it is when it doesn't work, when it's turned red. And when it's turned red, you should actually get an alert instead of like looking at the dashboard. I kind of agree with that. So I would say, instead of dashboard, let's just rely on alerts. Now that we talk about this approach, these tools and technique, as a developer, does that mean we have observability by default by now?
One of the things we do know from working with big data platforms is none of these tools are useful without the data. So it is imperative that devs take responsibility for instrumenting their code. As much as like in my mind, we should care about as much about instrumenting our code for when it's running in production as we should care about doing TDD. When we're doing TDD, we have to think about all the ways that the code can break. We think about our edge cases and all of that. So they're all the points where code can fail in production as well. Tests only get us up to the point where it's deployed in production. That gives us a good sense of correctness before it gets into production. But with our increasingly distributed, complicated environments where no matter how much we test beforehand, we can still have sort of catastrophic failures in production. So if we don't know exactly what was going on at the point of this explosion, we're kind of going in blind. So there's a lot we think we need to do. However, tools can help. We can build libraries. We can, we've been doing auto instrumentation for a long time. We just want to get as much data as we can. We want to think about doing your future self a favor. We mentioned the change in operating models in these sort of microservice cloud-enabled environments, that our delivery teams need to take more responsibility for owning the code that they push into production. So, we need to ship a bunch of these alerts, but there's no silver bullet. Ultimately, we still need to think about how our code is going to run in production. We want to think about this sort of debugging first mindset, and it's really closely related to the TDD mindset, I think. And the goal is to get to a world where we can debug our systems. We've got a novel incident, something we've never seen before. Being able to debug our systems without having to write new code and or redeploy. Like imagine that world. You know, you've been woken up at 2 a.m. We know it's an important outage, and we've got the tools to debug that. We've got this rich information. We have done our current self a favor in the past by shipping all this information.
So, remember this diagram that Andrew showed earlier? So all we want to do is, we want to remove all these tools around it. We want to adopt the event-driven architecture. We want to use event stream and ship all the events to our event stream. We want to adopt the data platform kind of ideas, and we're going to put everything in data lake. In this case, we have an example of how we can visualize it using BigQuery. It can be anything, because this is actually quite typical in the data scientist world, that they have questions, they have data, and then they use particular tools to answer the question. And this is kind of exactly what we're doing. Now, the other thing, we talked about alerts. So we can have consumer. In this case, the consumer, when something is wrong, can actually send something to PagerDuty. So for this particular consumer, it's just up to your imagination for what you want to consume and what you want to do with the events. The event is there already. So imagine you can codify your security rule using code and consume your event to make sure your system is still secure. So now we have been working on a demo, but we're not going to do a live demo. We're just going to show you some screenshot and also kind of the thinking process of how we can actually use a system like this. So we decided to use something called Jupyter Notebook, which is very popular within the data world. So let's say we have a very important customer. 80% of profit is from this customer. They called up and said, look, your system is kind of working, but then there are some requests that we are getting errors. Can you fix it? We're very unhappy about it. All right, let's have a look at this. So the first thing that we thought, okay, well, let's get all the non-200 requests that we're getting. So in this case, in the Jupyter Notebook, we just run a good old SQL query, and then we get some stuff, and then what we see is, well, you know what? It's 500 milliseconds. Something is not right there. In this case, we can validate that this is the client with the client ID there, and we know that this is with a request ID there too. So with a very simple architecture diagram next to me, I know that the /purchase will be serviced by something called a payment service. So I go ahead and do a query against the payment service event with the request ID. In this case, well, I validate that, you know what, this is causing an issue. So it helped me kind of focus on payment system, not good. All right, that's cool. Now, looking at the diagram again, I notice the payment system talks to a database. So the next question I have is it the database that is slow or the actual service that is slow? So once again, doing my query, I quickly got a diagram so that I can see whether there's a little bump. In this case, I found my request ID, and looking at the rest of the request, it's actually looking okay. There's nothing really wrong about it. So now I rule out the fact that it might be a database issue or the database being slow. Now, then I'm like, well, they said it happens sometimes, but it didn't used to happen. So now what I really want to know is when did that start to happen for this particular customer? So doing another query, whoa, there's a new version that came out. And then after the new version, we realized the request is quite slow. So now I know that we didn't fix the problem at all, but this actually gives us an idea as to where to look now. Now we know that this new version is not working, so let's have a look at the change set. Let's time box it so that we make sure we ensure our customer is happy. And we know that the previous version worked, so we can always just roll back when we ran out of the time box time. So what we actually believe is everyone can be a superhero. We all have that superpower inside us. But the tools, the process, and the technique that we have today doesn't allow us, doesn't unleash this superpower. So we believe that by adopting this new way of doing observability, it will help us to become a superhero.
And we want to come back to this idea that observability is for everyone. Again, this is not a new idea. The folks who popularized the modern observability movement, Charity Majors and folks, have been sort of pushing this idea that observability benefits everyone. But the reason we think it's for everyone is because we think this architecture, an event-driven sort of operations architecture, can open up all the data, all our operations data, to all the big data tools that we've been developing for a long time and have become standard in the data world. We need to stop reinventing the wheel and start using the good stuff and start using the patterns that let us use tools independently and bring in the things that are right for a particular job. And it's not just for dev and ops. Security people can pay attention to these things. They can consume these. They can get alerts based on particular things happening. We can also, we've got compliance in here. We can, as new things are rolled out, we can see whether they're meeting our risk and compliance needs. At the same time, we can start to instrument the customer-facing pieces of this and start to build a way to harvest customer insights in a privacy-preserving way. Because when we can cast off the shackles of Google Analytics and things, who are going to consume the data and use it for evil, we can start to learn about our customers in a way that respects their privacy and sort of gives us a leg up over the competition. And we can do all of this without sort of extra effort because it's just our default sort of delivery architecture. So that's why we think observability is and should be for everyone. Thank you.